In this program called Delete Node with Method, we're going to start by creating a list. We're going to get input from the keyboard and create a list of ints. And then we'll ask for an integer to be deleted from that list. And then we will go ahead and delete it. It's important to note that the integer that we want to delete must be in the list in this program. We'll fix that later, but right now it has to be in the list. So here is main. We're going to have a method to create a list and return the head of the list. We're then going to call another method to print it. We will ask for an integer that's going to be deleted. We will collect that integer from the keyboard. We will call another method that will delete that integer from that list, or rather delete the node that contains that integer from that list. And then we will print the new list. So that is main. Our print is a little bit different than we've used before. Right now we're just going to print out each item followed by a space, and then at the end of this while loop we will do a print line so that we are ready to print the next thing on the next line. Here is our create list. I'm sure we've done something like this before. We will stop at 0, so we will ask our user for integers. 0 to quit, they can be positive or negative, and as long as it's not a 0, so we'll pick it up. And I'm sure you will remember that with a while loop you have your input above the while, and then you have your input, the last thing that you do in your while loop. That is the pattern of a while loop that depends on input. So as long as the number that you're picking up is not a 0, make a new node pointed to by temp and put num in it. Head is a special case, so if the head of the list is null, in other words you don't have a list, then you make the head and the tail both point to this new node that you just created. Otherwise, else. Tail.next is temp, so this is an append, and then tail equals tail.next, so move tail along. So that is our creating our list by appending. And now we're ready to look at the delete. Now this delete takes as parameter a node, which is the head of the list, and an int to be deleted. So we need to traverse our list looking for the item to delete. As always, the head is a special case. So if the number we want to delete is the number that is in the head, the head's item, then move head along. Else. So it's not the head of the list. So we'll set a node pointer to point to head. We will get the int in this is not num, then we will move temp along and get the item in the next node after temp. So let's look at our sketchpad. Let's see if we can get them here. So we make temp point to head, and then X is the item in temp's next. So here, let's join these up. X would be 7. So x is 7. This is the value of x. And let's imagine we're looking for 4. So x is temp's item. Temp is pointing to head, temp's next item. So x is 7. It's not 4. And so we'll move temp on to the next node. And then x is temp's next item. So temp's next is this node here, and its item is 4. So x is now 4. It's the item in the node that follows the one pointed to by temp. While x is not num, well, it is. This is the one we wanted. So I'm out of this loop, and when I exit the loop, temp is pointing to the node in front of the node I want to delete. There's no point in pointing to the node I want to delete because there's no way to get back to the one before it to hook that up to the one after it. So now I'm out of this loop and I say temp.next is temp.next.next. Temp.next, that's this, let me do it in blue. It's this guy here is temp.next. And I want it to equal temp.next.next. So temp.next is this node, and temp.next.next is the node after it. Let's just move this along a little bit. Move our sketch pad along. So temp.next, that's this guy here, equals temp.next.next. Temp.next is this fella here. Temp.next.next will be this one. So that does this. That's the effect of line 79. So our list now 11, 7, -1, and we have eliminated the 4 because this pointer got altered. And then we return the new list. This only works if the number I'm looking for is actually in the list. Let's just verify that it works if the one I'm looking for is at the end of my list. So let's go back to where we were before. And we started temp off here, and let's say we're looking for -1. So this is what I'm looking for to delete. So I'm starting out by saying x is temp.next.item. Temp is pointing to head. Temp.next is this node. Its item is 7. So x right now is 7. And then while x is not num, it is not. So temp is temp.next. So I'm moving temp on. No longer pointing here. And x is temp.next.item. Temp.next is this guy. Temp.next.item would be the 4. Up to the top of the loop, while x is not num, which it isn't. So temp is temp.next. So I'm moving temp on to this node. And x is temp.next.item. Temp.next is this node. Temp.next.item is -1. go to the top, and while X is not num, but it is. So I'm out of my loop and I set temp.next. That's this pointer here to be temp.next.next. Temp.next is this node and its .next is null. So that sets temp.next to be null. And so I have eliminated the node that contains the -1 and then return the new list. Again, this only works if the number that you are trying to delete is actually in the list. I have no way of saying, too bad I can't find the number, because I can only return one thing. And the thing I want to return is a node. It's the pointer, the address of the first element in the list. And I cannot return anything else. So I need a way to deal with that, and that will be in our next version.